Stay tuned to learn how quantum foam teaches us how to think about the fabric of space.
I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller of Simi Computer and IT Solutions.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 1 p.m. on Saturday in Hong Kong for now. Next week, we spring ahead, so it would be over at this point. So if you are in other parts of the world and you do not spring ahead, I guess it's starting an hour earlier, right, for you?
Mm-hmm.
Okay, so we are broadcasting live from Thousand Oaks, California. Thank you so much for being here.
Please vote. We have 2 potential Zooniverse projects for next week. Both sounded interesting to us, so you get to decide. The first one is Galaxy Zoo Tidal Tales, and they say help us decode the remnants of cosmic collisions. So it's looking for the tidal tales of galactic collisions.
Tidal as in tidal waves, not title of a book.
Yeah. And the other one is Space Umbrella, help uncover Earth's magnetic shield in space.
I got a 2.
So let us know in the comments which one you want to see next week. We'll count them as we go through the episode. And we've got lots of comments already, but not on that. So
Hey,
Cliff says,
welcome.
hi from rainy Queensland. Yep.
Still.
Yeah. We've had some rain, but not nearly as much as you guys have. Hi.
We never will.
Yeah. Hi, Scott.
Hey, Scott, welcome.
And
might as well show that Galaxy Zoo. Oh, did we just get one? No, there's 2.
Yeah. So these are the 2 things that we're choosing between. Smokey's $2.99. Hi, I think you're new here. I don't recognize you, so welcome.
I've got a 2 there.
Oh, okay.
Another 2 from
Okay.
Scott.
Hi, Don.
I think that's Scott.
Yeah, that's Scott. So we've got.
Hey, Don, welcome.
2 for Space
2
Umbrella.
for 2 2s. Awesome. We really appreciate your help. So we just, I don't know. Let's let them decide.
Yes. Yeah. Because they both sounded interesting to us.
Very definitely.
And we were going to flip a coin when we decided, hey, you guys can do that for us.
Get a vote instead. All right. So tonight it's Quantum Foam by Sleepy Scientist. How to think about the fabric of space. We'll be back in 8.3 seconds. There's a link to that book in the description if you want a signed copy of the book. Write to Pam at everydayspacer.com for details. I'll get it eventually.
Okay. So Dan says 2 also.
2,
so that's
excellent. Oh, good.
That's 3 so far for 2 because Scott said 2 and Smoke said 2, and Don is greedy. Don is getting greedy.
Yes, we can do both, but probably not next week unless one's really short.
Yeah,
we've done that before. It was just 2.
Right. So Don, which one do you
easy.
want to see next week? Like I said, both of them interest us, so you'll probably be seeing both of them, just not one after the other. We'll probably put the other one in our back pocket to pull out.
Yeah, yeah, especially if it's still not completed. That's when that works. Fun fact about
space. Well,
space is big.
Yeah.
How's that?
We're going to be talking about that. That's what this episode is about. So, so that's 4 for.
All right. Oh, I'm so glad we did that.
So.
Thank you very much.
Unless we get 5 other people piping up, it looks like it's going to be space umbrellas. But we'll still keep count throughout the rest of the episode.
We will. Yeah. So empty space isn't empty, and photons prove it. What if space-time itself isn't smooth, but restless beneath reality? Our audience member, Sally, found an interesting video by Sleepy Scientist. There's more to that title, but we'll get to it when I show you the channel. We watched most of the video, and we have some thoughts on it tonight.
Yeah. Tonight we break down a fascinating exploration of quantum foam vacuum fluctuations, and the deep structure of space-time. How do quantum mechanics and gravity reshape our understanding of nothing? Why have distant quasars ruled out many quantum foam models? And what do photons traveling billions of years tell us about the limits of modern physics? Pam will start off discussing the video and what we learned about the channel.
I'm going to share a couple of links too because, oh, I meant to bring the book. Doggone it. I do have a copy. Whoops, where'd it go? I do have a copy of the book that I put into this. It's also in the description. It is Universal Foam by Sydney Perkowitz. We've been out most of the week at a conference, so we're a little bit less organized than usual. 42. Oh, that's the beginning of it. Oh, okay. He's got the comment. Yeah.
So yeah. Yep. So 2. So that's 5 votes for Space Umbrella.
Awesome. So if you were here last week, you may have had a chance to review the video and even the book we mentioned. Let me go ahead and pull up that. Oh, you know what? I didn't share it. Silly me. I'll go back here.
Please,
I'm a little sleepy.
Hang on while we...
One moment, please. Share your screen. That one, right?
Yeah.
Oh, and it's such a cool picture. Look at that. All right, quantum foam and photons. What's the fabric of space-time made of? So this is the video in question, and it is a little bit long, 1 hour and 44 minutes and 19 seconds. Now you'll notice there's lots and lots and lots of really, really interesting graphics. I believe they are AI generated.
Yeah.
And there's plenty of information in the description from this Sleepy Scientist Stories. So that's always cool to, find a new interesting website of a YouTube channel of videos. There are parts here, but they aren't formatted the way that YouTube likes to see them so that you can hop around to them. It basically break up this line here, and also it would give you a blue link, kind of like these are links, right? And you could pop between them. And this is what Jeff was talking about. This topic here, they go into it. It's great. It's amazing. It's very interesting. There's lots of cool stuff in there. And then you listen to the next one, and there was some repeat stuff, I think.
Yeah.
And I think we got through about 1 hour and 22 minutes of it. And honestly, I felt just a little bit like it was a little bit repetitive. It was
very repetitive.
It got a little wearying. It was just like, okay, I gotta stop. I gotta take a break. I gotta watch. I gotta do something else for a while. There were a couple of anomalies too. I thought, like at 8 minutes and 20 seconds, all of a sudden it was like a different language. It sounded like Chinese. Oh, do we have more comments? Good. Let's do that.
Sort of. Smoke says Elon Musk and Kamala Harris are making their own planet. What do you think about this? Well, I think
no idea.
I think you either are under-medicated or over-medicated.
Maybe that's what the smoke is about.
Yeah. Okay.
Someone new. Welcome. Oh, yeah. Yuri's day is coming up. Yuri's night is coming up soon.
Yeah.
That's cool.
Yeah.
And so at 1 hour and 1 minute and 54 seconds, it started to sound like French. And then again, at 1 hour, 15 minutes and 57 seconds, it sounded like...
Yeah, for only a few seconds at a time.
Right, but it was just weird. Like...
Yeah, it was definitely an AI glitch.
You're like, what's this thing doing?
Yeah, and the repetition is, like, there are 10 different chapters.
Yeah.
But there's no breaks between them. And they only, like, say, part 2, part 4.
Yeah.
And so there's no visual break. And so I suspect that the repetition is repeating stuff from previous chapters that are relevant to this one. But without any breaks, it doesn't really come through that way. It just comes through as repetition because they repeat verbatim, including the same graphics. So,
yeah, exactly.
So it's very wearying to watch. I mean, it's kind of like
didn't we just see this? Didn't we?
Yeah, and
so it's a little bit confusing too. Like, I don't think I've gotten to this point yet.
And the way they repeat, they don't like summarize the previous thing. They repeat the previous thing.
Like, yeah.
Yeah, and so the structure of it, I'm not a huge fan of. It'd be nice to be able to jump from chapter to chapter, from part to part.
Right.
And it would be nice if it's going to be one long episode, because that's the way it watches. It watches as one long episode that just repeats the heck out of itself.
Right.
Instead of 10 different parts.
Right. And one of the things that YouTube offers to have, and it starts with you have a 0:00 space, and then you put the words in, like this one has, why does physics refuse? Why does smooth space-time break? All these different ones, so that you can in fact find from a search that spot in the video. I don't know if you've ever done that, but you just searching for something and you pop up in the video and you're kind of like in the middle of it somewhere, right? It's like, well, that's weird. Well, it's because of this chapters thing. We just kind of learned about this, how to do it, why to do it.
Yeah.
Those kinds of things.
And if you want to see it being done, look at some of our more recent videos.
Right.
We will eventually do it with this one once we're done filming and the AI is set to do the chapters. But if you look at last week's and a couple of the other previous ones, we've chapterized them so that you can jump to various things. Oh,
right. Yeah, we got some more comments, right?
Yeah. Cliff says, repetition is ramped. It's hard to find good shows. Yeah. Oh, and don't start me on AI. AI is kind of useful, but
it's a tool, like any other tool.
If you use it for all your content creation without supervision, it's not great.
I think it has its place.
Yeah. Are we guys?
We're going to make too many mistakes to be AI. And we had a discussion about it. We decided we didn't want to have us show up as AI. We could.
Right, yeah, we could do it AI, but
oh, there's Sally. Yay.
Hi, Sally. Hey, Sally. There's a vote between a couple of episodes. Let me get this.
A little higher. Oops.
There we go.
There it is.
There's Sally. These are 2 episodes that we're looking at doing next week. Just give us a vote as which one you want to see.
They're both Galaxy Zoo
they're
projects.
They're both Galaxy Zoo projects. So it's just they both sounded interesting to us, Sally. So so it's not like you won't see the other one, the one that you don't vote for, but
especially if it's still got project material to work with.
Yeah. Okay. Go.
So this is the channel in general. It's called, see there you go. I make mistakes. Sleepy Scientist Stories is a fairly new channel. It has 157 videos. It's got 45,300 some subscribers, and you can read more about it. And this explains it, because welcome to Sleepy Scientist Stories 13.8, a quiet corner of the universe where science meets dreams. Here we tell long, soothing bedtime stories about the cosmos, time, nature, and the mysteries of physics. So that kind of explains a lot.
Yeah, we have watched this episode in parts because we kept getting sleepy and going to bed.
It wasn't quite that bad. But yeah, this is from August 30th of 2025. So they're doing very, very well. That's awesome to see. Yeah. They don't have a whole lot, though, and it's been a couple of weeks since they did the last one. But yeah, basically this is your channel. Lots of cool graphics. I think what we're watching is pretty much all AI. I don't know if Sally knows for sure, because she's going to know way more about this particular channel than we do. But it felt a lot like it was entirely AI. Yeah. And I don't know if the person behind this has created the content with AI completely, or if there was some, I just don't know. Don't know.
We'll use AI to create the descriptions and stuff like that.
Well, to give us a starting point.
But we always look at it and go, what is the actual description, and edit it, from that. But AI is a good, so smokes, AI is a good starting point, but you can't use it as a crutch. You can. Yeah,
I think it's a good tool to overcome the blank page syndrome, where you just have this blank page in front of you, like, what do I do? What am I writing? You get a starting point. And personally, I'm pretty good at editing.
Yeah.
Starting, sometimes it's a little tough. So we got some more comments, I noticed.
Yeah. So don't you guys fall asleep? Yes, especially when watching this video. Oh, sorry, Sally. I know you recommended it, but wow.
And there's a lot of really great content in it. It was just a little repetitive, a little hard to continuously, watch it all in one go.
There you go, Sally. We can't keep it up forever because when other comments come in, we have to show them. But there you go.
And you might as well read it off again. Galaxy Zoo Tidal Tales.
Oh, okay. Yeah. Galaxy Zoo Tidal Tales help us to code the remnants of cosmic collisions, which is basically looking at the shapes of galaxies after they've had collisions. And Space Umbrella, help uncover Earth's magnetic field in space.
We both sat there going, oh, these both sound really interesting.
Yeah.
So we turned it over to you to vote on.
Yep. And Sally says, I have no attachment to that video. Oh, good.
We do appreciate the recommendation and finding a new source of information. It's really great.
And there was some good information in that video, and I'll be covering that later. It's, so yes, it's there. I think it really could have done with some better editing. I mean, if they might have stretched to make it an hour 45, I don't know. But it's, there's a lot of good information there. I think it would have been a good half hour to 40-minute show.
Yeah, I think so too.
Yeah. Stargate. I can try it the next time I want a video to fall asleep by. Okay, so Sally, again, number 2. Okay.
No, number 3. I thought that the graphics did help to ground the material at times. And one of the things I noticed too, because we started it and I went back and I started over because there were parts of it I was like, I don't completely understand this. But by the next time I'm hearing it, oh, okay, I get it. I kind of get it. Sometimes very technical things go over my head a bit. I kind of hang on for dear life, but sometimes I think Jeff's a little bit better at really following the trail with some of the more.
Well, I've been into physics for a long time, so not a lot of this isn't like totally new to me, just new stuff added on to other stuff. So
still, thank you so much, Sally. And I think Jeff has some kind of specifics about the material itself he wants to talk about, right?
Yeah, so, but cool. We can come back to us because I don't really have anything to show. Just what I learned from this video. So according to this video, and I'll say this right now, I haven't seen anything in this video that I disagree with.
Yeah, it's very good content.
Yeah. So nothing of it breaks my current understanding of physics.
Yay.
Some of it made me go, huh. And, yeah, that makes sense. So that's always good.
I got a comment. I like this one because I got to tell you, Smokes $2.99 is all space. Some of us just want to go somewhere else in space. Yes. Have you guys ever been to space before? There is nothing else, my friend.
Now, yeah. Take a look at the Earth from a satellite view.
Or the moon pictures.
The atmosphere is so thin. It's kind of like an eggshell on a hard-boiled egg.
Ooh, I like this one. What's at the end of space? What if there is no end? Like the egg example of where's the end of the eggshell on the egg, on the outside of the egg? I don't know that it has an end.
Yeah, Smokes. What we believe so far, based on everything that we've been able to see, is that space is truly infinite. Now we can only see 13 billion light years of it, 13.5 billion light years of it, or whatever it ends up being. The actual distance, well, one changes every year, but also our understanding moves that goalpost a little bit, but not by a lot. So we can only see 13.5 billion light years out, but that doesn't mean that there's only 13.5 billion light years. It means that there could be, and most likely is, more space past that.
That's just the best our machines have been able to do so far.
Because if you think about it, things work differently at the edges. And if 13 billion light years was the edge, things would work differently there than they do in the rest of space. So space is bigger than we can see.
Yes.
And so what can we say about about the space that we can't see? Nothing, except that we assume that it works the same way as our space.
And Smokes is on fire, so to speak. Do you think there's life on Phoenix A? I do not know what Phoenix A is.
And here's the thing with.
You know what that is?
No, I don't know what
okay.
that was specific one is.
All right. I was like, wow.
And we've covered this in some previous episodes, is that I personally think that life is going to be fairly common in space. We'll find out once we get under the ice of Europa and see if there's life under there, because there are all the building blocks of life there. So if life is there,
seems to be right.
If life was generated there, then life is going to be very common. If life wasn't there, then life won't be as common out in the universe. That's kind of going to be my litmus test.
I just think of all the different environments here on the planet Earth. I mean, they found these teeny tiny little black worm things in like the coldest, snowiest place on the planet. Like,
yeah. But,
I mean, wherever there's like energy and
water.
So
for Earth life, yeah.
For Earth life, yes, that's a good caveat, because who knows what anything else might be like.
Right. The other thing is that although personally I think that there might be life on other planets, I think that it's very unlikely for it to be complex life. I think single cell and very basic life forms are going to be the most common, because it took something specific on Earth, mitochondria being absorbed by certain cells, to give cells the energy to clump up into more complex life.
Right.
So, it's just one more hurdle that life has to go through to become complex. So, go ahead.
So, PHX Snoop, can you have kids in space? We already do. Look at this planet. It's 8 billion people.
Right. But I think he means in microgravity.
Oh, microgravity. Okay. See, I distinguish between them.
The answer is maybe.
Maybe.
Because they don't know what effects gravity has on the development of a fetus. Now, can you impregnate an egg in space? Yeah. It doesn't care what direction is up for that. But they think that some of the developmental stuff is gravity dependent. Now,
of course, we developed on a planet with gravity. So.
Right. So, but we don't know. But we're probably not going to experiment on humans for that. Now, we also have the moon sitting nearby. So if we can't have babies in microgravity, we might be able to have them on the moon if 1/6G is enough. We'll see. Otherwise, we need to spin something, make our own gravity.
And we've seen some issues with seeds, like they've talked about planting seeds in various gravity. I think they've done it on the space station, where they could kind of pick and choose gravities, sort of. And
the roots and the stems don't know which way to go.
Yeah.
Okay. So
I love this, Sally. And you are answering that question of life forms with the bias of 3D.
Yep. Well, that's all. Sally, we only know 3D. That's the trouble. My bias is I can only talk about what I know.
I don't know. Sometimes I feel like I get close to the 4D thing.
Yeah.
A couple different things have happened in that realm. Let's see. When are we going to be able to breathe in space?
Well, there's nothing to breathe out there unless you bring it with you. I mean, that's...
Yeah.
You have to put a can around yourself in order to be able to breathe in there. Breathe in space. So you have to bring something to breathe.
Oh, boy. Living on the sun would be very hot.
We don't have anything... We can't build anything that would survive being on the sun. So I don't think we'd be able to be on the sun.
That would be, very challenging.
Yeah.
I agree with Jeff, because DNA is made of some of the most common elements in the universe.
Yeah. And DNA is only one way to have replicating system. So um,
Is Sally taken?
I can't answer that.
No idea. I have no expertise in that area. Wait, what? They're fighting. They're fighting now. Okay. All right, we're talking about science, space exploration, science, and astronomy here.
Yeah. So yeah, I don't. There's a lot of stuff that we don't know. That a lot of people believe that there will be issues with pregnancies in space. Heck, some people believe that there's going to be issues with even just the way our bodies operate in microgravity. So we might have to make gravity, just by using a spinning cylinder or a spinning ring to make gravity, because there are certain processes just in our own body. On the macro scale, blood doesn't, go down to the feet, so your face becomes puffy. Because on Earth, gravity pulls stuff down.
Yes.
And also our bones need the impact of walking in order to cause microfractures to get them to rebuild and stay strong. So we're going to have to make gravity by spinning stuff. We're going to have to bring our canned air. I don't think anyone's going to be breathing vacuum. Actually, nothing developed on Earth, I think, will be able to do that. Even tardigrades, the hardiest thing around, can't breathe vacuum. However, they will just dry out and float around. And as soon as you put them in air and water, they revive again.
That is freaking fascinating.
Yeah, we talked about those in a previous episode. But even so, they aren't breathing space. They're just surviving it.
Yeah.
So,
we got some comments here, and honestly, I think I'm going to skip some of these.
Yeah.
Thank you, Scott, for chiming in.
Yeah.
Yeah, very good.
Yeah.
All right.
Vacuum is, suction is involved.
And there's lots of stuff out there about it. One of the things that we do a little differently is to talk about things that you can do, because I think a lot of people can tell you about space. They can report to you about stuff. But I don't know that there's a lot of people out there saying, oh, here's this cool thing, and you can participate.
Yeah.
And one of the things about this being a live show, honestly, I hated to do the editing for a, canned show, is that we have your comments as well. We have a chance to interact. You talk to each other in the chat, and I think that's kind of unique too. Yeah. So we're really happy to provide that for you here. The space to work it out every Friday night at 9 p.m. Pacific time.
Okay, so
can you ride a satellite?
Yeah. Oh, just in answer to your question, Smoke.
Which one?
The first one
the
up
bathroom
there.
Here?
Yeah.
Okay.
Is that ISS does have space rated, microgravity rated toilets, and if you can look those up.
Yeah, tons of stuff out there.
It's known engineering.
It's like one of the first questions people ask.
Yeah.
Which, like, it happened here. One of the first questions.
So Smoke also asked, can you walk to Mars?
Oh, to Mars. Good luck with that.
Well, if you're in a spaceship and walk while you're in the spaceship and do laps, yes. But, vacuum, no gravity. You need thrusters to get there.
We're having a funny night tonight. Thanks for being here.
Yeah. Can you ride a satellite? Well, unless it's a satellite like a moon or something that's big enough to have gravity, you'll have to hold on real good.
Oh, okay. There's a great Korean English series on Netflix that focuses on whether or not conception is possible in outer space. Okay, we need a title, Sally. Please. Thank you so much. That sounds fascinating.
Yeah.
Korean even. That's wild. Okay. Yeah, interesting.
Because, it's truly like we don't know necessarily.
I don't understand Korean.
Yeah. Well, it is in English.
It sounds like you get English too.
Yeah, and it does have subtitles.
Yes, okay.
Yeah, so.
I can't tell if this is two different people, the same person talking to themselves. What are we doing? What's happening here?
Maybe you guys know each other. I don't know.
Maybe they do. Yeah. All right. I'd be curious to know how you found us.
Yeah. Okay. So, what did I learn from the video? Because we've talked about the video, but we haven't talked about what's in the video necessarily. Okay, here are some things that I learned from the video, and our current understanding of physics, there is some fluctuation to vacuum. Basically, zero movement to the vacuum is actually a higher energy state than no movement. And we talked about energy states of vacuum in our episode about vacuum decay. So chances are real good that there are fluctuations.
Yeah.
And
well,
so
they actually did some experiments. They removed all the different things that might affect what's there in space, and it's even though it appears to be nothing, there is still some kind of moving and changing and differential.
Yeah. Okay, so Sally says
when the stars gossip.
Yeah. Okay. So
fabulous.
Thanks, Sally.
Okay.
Good answer. Good answer, Sally.
Wait, what?
Sally is not she's answering.
I get that one. It's the next one. Like what?
Okay.
Yeah, we're not doing that here. What is the percent?
Very, very, very small.
What? Oh, okay. The odds. What are the odds of our sun exploding tomorrow?
Yeah. Okay.
I'm gonna go with almost none.
Yeah, almost none. Basically,
negligible at best.
It's scheduled for about 11 billion years from now.
You can wait.
Yeah, about 3
Good
or 4
luck.
billion. It's going to expand enough to basically give Earth a really bad day, but and so we won't be around for it necessarily unless we're not on Earth. But okay, whatever, Cliff. Thanks.
Yeah, we're not really that kind of a show of PHX Snoop.
Yeah, we don't do politics.
We talk about space exploration, science, and astronomy, and how you can get involved, because most people think it's for rich guys, the government, and Katy Perry, and we know that it's for you too.
Yeah.
We just talk about how.
Yeah. So
there was a whole book about it.
So the main question here is, how big are the fluctuations in space? And the video uses observation of quasars and other light sources at the very edges of space, by Hubble, James Webb, and other like the ESA telescopes to provide the observational data. So everything else is totally based on what doesn't break what we can see. And the running theme here is that there are a lot of theories about fluctuations in space, but we can with our observations we can just throw out any that don't match the observations. So
well, and the fascinating thing I thought, there's a couple more before that. The fascinating thing I thought was that the photon that travels from that great distance to us carries its story along with it, and and I forget how we know that. How do they say we know that? I forget. Maybe Sally remembers.
Yeah.
Because she, like I said, she probably really knows, because she got to this way before we did.
Yeah.
But yeah, it was just fascinating how, like, even though it's come all this way, and that was the whole point of it, was the photon carries the story even from very great distances, and it's consistent.
Right.
It doesn't.
So
there was a lot of different things about it. I really think you should watch it, even though it's kind of repetitive. It's consistent, and even though like there's stuff in the way, they all kind of got here at once, kind of thing.
Right. Yeah. Well, here's one of the main observations about it, and this is what they use to make the rest of their conclusions, is that photons are only affected by the curvature of space. And of course being absorbed and emitted, like you produce a photon or you absorb a photon, but they don't talk about those because that's different. That's other stuff.
Oh boy. Very lively crowd tonight.
Yeah. So, and they're not affected by their energy level. It was believed that higher energy photons travel faster than lower energy ones. But they
I missed the higher lower part. Interesting.
They
yeah, let's get to them in a minute.
Yeah. So but they've observed like supernova and other distant uh, events, and all of the light arrives at essentially the same time. So
No matter like what's between
right,
here
yeah,
and there.
yeah. Well, and just the speed of the light doesn't vary based on the color of the light or how energetic it is. So we know that
Okay.
that doesn't affect it. Also, we know that gravity doesn't affect light. Now, the curvature of space-time, which is a result of gravity, does, but not the gravity itself. And the reason is because when light curves around something, it doesn't spread out. Like there aren't like different types of photons that are affected differently than others. They simply follow, they'll all follow the same path, no matter what color the photon is. So,
And they talked about gravitational lensing,
right,
to
and that's what I'm talking about here.
help us understand this. I think
Right,
is
yeah.
what, yeah.
Yeah, so the gravitational lensing of mass curved space-time, and a photon in its own observation is traveling in a straight line. It's just if space is curved, they follow that curve, but but there's nothing telling the photon itself that it's not going in a straight line. So it just follows the curves of space-time. Now, since they've determined that space fluctuates, that causes a problem. Because if space fluctuates enough, then these photons, think of skimming along a lake that has a choppy surface. That boat, without any steering, is going to end up in a random direction just because it'll hit different things at random times. And light doesn't do that. Light will stay going in a straight line no matter what space is doing.
Right.
So one of the main things that this talks about is that the maximum, the fluctuations have to cancel out because the light travels in a straight line. It isn't biased one way or the other, up, down, whatever. Doesn't get slower, doesn't get faster. It just keeps going. So they all cancel out. The fluctuations also have to be small enough that, because if they were big fluctuations, and even if they canceled out on the macro scale, the light could still veer off course.
I'm going to start here when
Okay.
you're done. When you're done, I'm going to start right there.
Yeah.
Because that's an inside joke. That will be.
Okay.
We'll have some fun with it.
Okay. So the fluctuations have to be small enough that they cancel out. They have to be so small that the cancellations, that when it, evens itself out, that the light can, go through it without being affected. So the biggest takeaway from this is that those fluctuations have to be super small. So any quantum foam equation that makes fluctuations big enough to cause light to not go in a straight line are out. They just basically, that's a litmus test of just basically pass fail. So most of the theories are gone just from that, because otherwise we would see, like from a quasar, it would look fuzzy, not a point, because the light would be spreading. And quasars are like the most distant things that we can pretty much see. They're super bright and they're super early in the universe, and so we can see them, but we see them as point sources, not as fuzzy blobs. So that's the main gist of it, is that there is a fluctuation, but it has to be so small. And we're talking small. Even nanometers are like big compared to these fluctuations. These the size of an electron is big when we're talking about the size of the fluctuations.
Okay.
So they're small. And so that was the gist of this, is that it basically puts a cap on the size of the fluctuation, and it shows that through observation you can filter out a whole bunch of theories, because if they don't match observation, they're not true. And that's the that's the gist of it, is that we throw out everything that doesn't match observation. Then we've got a bunch of theories, the few theories that are left. We need to learn how to observe different things so that we can figure out which of those are real. Because you can argue about how many angels it takes to can dance on a head of a pin as a whole theoretical thing, but unless you can observe something, you can't know what's true. So that's one of the things that I really like about this, is that it takes the theory is great, but it has to match what you can observe.
Yeah, it's really kind of fascinating that we do have interesting new tools like the James Webb Space Telescope
and LIGO and
LIGO, right, that are helping us to get there.
Yeah. And
that's what I think is so fascinating.
Yeah.
And that will just continue to go on.
Yeah. And I think that there's a lot of observation out there right now. We have enough tools out there that are taking so many photos. And we're talking about Zooniverse projects. One of the reasons for the Zooniverse is that there's so many images out there that, even a single scientist or even a team of scientists can't go through them all.
Grad students.
Yeah. So they're crowdsourcing it,
That's how it got started.
Yeah. Yeah. Galaxy Zoo. Yeah.
The general public, and then things, what was it? Months within, they thought like some number of years it would take for this team to actually get through all these. It took months for the general public, and the general public really enjoyed that.
Yeah.
And
so they made a whole thing of it, and now there's a whole bunch of different projects up there. So
some other benefits too, because if there's enough people, there can, a whole bunch of people can look at the same thing and decide.
Right.
And if there's conflict, then the scientists can come in and, let's really, really understand what we're seeing here.
Yeah. You can say that it's this or that. And if like 50 people, and they have more than one person looking at a single image.
It's like 12 or something. 12 to 100.
Yeah.
I think I've seen in there. Yeah.
Yeah. If 50 people say that it's the one thing and like 2 or 3 say that it's another, they just assume that 2 or 3 people made a mistake. Now, if 25 say it's one thing and 25 say it's another thing, the scientists go, we need to look at that.
Time to take a closer look.
Yeah, time to take a closer look.
Yeah, right. All right, before you go there, did you finish your notes? I see a bunch here.
Yes.
Okay, great. Because I would really like to tell you that Simi Computer and IT Solutions is now a sponsor of Everyday Spacer, and we really appreciate that. It's there's ways to get help from even this distance. And if you want to call Jeff, 805-584-9199. You can book a consultation, different things. But yeah, Jeff is a computer genius, basically. He's been doing this kind of thing almost your whole damn life. Since you were a kid.
A teenager, yeah.
Yeah. All right. So I'm going to go ahead, because some of these do not pertain to our episode, our show. We're really not going to address them, like this one here. I'm not going to really talk to you about that. But I do want to talk about this because, and Sally, it's an inside joke. High Bay Bob is one of the kind of characters they've dressed up and lives in the JPL, which is Jet Propulsion Laboratory, clean high bay, so that when there's nobody working in there, you can get a feel for a person in the lab working on something that you can actually tell. It's like you put a quarter next to something so you understand
it gives you a
the
sense
size.
Of scale.
Yeah, sense of scale, right? So let's see, what else do we have here? I don't know. I don't have any expertise in that. Let's see. Stars. I can't see how.
Okay, for one thing, there's nothing that we can do to even affect our own sun.
No.
Let alone any
Not
other
really.
Sun. So yeah, there's nothing.
Yeah, Elon Musk, we very much appreciate what he is doing, and I'd love to get him on the show. Wouldn't it be fun? We've done a profile of Elon, so if you want to go looking up that previous episode, we've talked about him there. Sharing this live stream with family. Thank you very much. And let's see. I don't know that you can, because it's all locked down. There's just kind of no way to do that.
okay, here's a, if it's off, nothing. If
Yeah.
it's on, the electromagnets are so powerful that it'd kill you just even without the particle accelerator running a beam.
There's-
Just the electromagnets in it would you'd be toast.
But
Yeah,
no way to get in there.
yeah, they won't let you in because they need to keep it super clean. You know,
Yeah.
You know, it needs to be a vacuum in there.
Right.
So
Yeah, nothing to do with that. I'm so sorry, Sally. We've kind of lost track of what that's all about there. Okay, that's nice. Don't know. Too much information. Yes. The hub. Oh, the hub. What's the hub? Because, okay. Hub. Tell us more. Tell us more. Look at Shell today. Does that mean you know us? It is a real gold chain? Well, that's a really good question because it probably kind of shouldn't be black, right?
yeah, right.
Wasn't there a theory about
smokes?
that?
Just so you know, yes. I've had it since it was high school graduation present. Just so you know.
Nice. Let's see. Oh, what? No.
Yeah.
Nope. Nope. Nope.
And
Yes. Hi. Yeah. Nope. I'm not gonna show that one. That's the nature of the show. All right. So, do you have more?
oh yeah.
I very much enjoyed that.
Smoke said, "Is that the Jeff?"
Oh, I missed some. Sorry.
About the IT. Yes. Yeah, I do.
Sorry, I thought
I
it was
do
done.
cybersecurity. Okay. Oh, I think you mean photon. You say protons there, but I think you mean photons. How Carrie's story. I think Pam was talking about how they basically tell what they passed and stuff like that. I have no idea if there's any kind of consciousness there. I personally don't believe they do, but you know, I have as much, you know, I don't think we have anything that can measure that. So I'm going to say my belief is no, but I don't know one way or the other. So,
yeah, it was photon in the episode. Yeah. No
no,
idea what your skill level is for one thing.
Yeah. And
it seems it's probably air gapped, right? It's like in space.
And here's the thing. The systems there are so basic that I don't think that they have anything smart enough for you to hack. They're talking electronics, not computing on there. Now there are some instruments that do talk to the ground, and theoretically you could hack that instrument, but it wouldn't do anything. You wouldn't be able to do anything except vandalize a single experiment.
Yeah, no, we weren't going to do that one.
Okay.
Why are you showing it?
I didn't read it yet.
Okay.
Yeah.
Try and read them, please. Yeah. All right. Cool. Love the lively discussion. We do have some constraints on this show. We are talking about space exploration, science, and astronomy. All other things, we either have no expertise on it. We're not going to go there. It's just not that kind of show. Who knows? Someday one or both of us will do something in the realm of something else. But right now we're doing this.
Mm-hmm.
So, all right. Did you want to say more?
No, that's pretty much
okay.
All I've got. There might have been something in the last 20 minutes, but I don't know because we quite frankly didn't have time.
Yeah, we've been out of the conferences. Glad that you're wide awake. We're not going to do that one. So I'm going to go ahead and talk to you because this year we are building some new products and services. And I do actually have this one here that I created that goes along with this. And I have this here for a different purpose. It's the Old Farmer's Almanac. Apparently it's the one that's existing now. I think the other one, they went out of business, which is kind of sad, but this was my favorite anyway. Once upon a time, I remember they sold 9 million a year. So I have created a companion product that goes with it. Now, maybe there's something you know about that you might want to have built, and I would love to help you out. So yeah, just think about things that might be useful. And if you ever sit there and said, gee, I really wish I had this, I might be able to make it. I've done some other things. Every now and again, we make some offers, that kind of thing. What? I don't know what that means. Oh, wait, what? You don't know how to read it. Read it for you. Actually, that might happen. So stay tuned.
Yep.
And then tired. Okay.
Well, well, here's the thing. I said that the video that we watched was somewhat tiring to watch. So yeah, if you watch that video, and Pam put a link to it in the chat. So
take it in sections, because then you'll have like some understanding, and then you'll go away. You come back and you get another chunk of it, and there might be some different things in there, but it might be the same. Yeah. I think that's a really great way to chunk it down. Watch chunks of it at a time, maybe even the parts that they described.
Yeah, it's really hard. You have to pay attention to when one part begins and another part, one part ends and another begins.
Yeah, as soon as they say
they don't chapterize it, so it's not easy. Yeah, it's not easy.
Might be a good time to stop. So Dawn's got a nice comment.
Yeah. So through spectroscopy, photons tell the story of what elements are present in astronomical objects they come from.
Right.
Yep. And pass through, because photons that pass through things, some are absorbed by certain elements, and so you see gaps in the spectra.
Yeah, there's two things: the
emission and absorption.
Right. Yes.
So yeah,
exactly. Let's skip the next two.
Yeah. So,
Cliff's got it good.
Yeah. So whatever the photon bounced off of, it carries information like color, like a telescope, and something far away that you can see a whole lot more with it. Yeah. And something far away you can see a whole lot more with the telescope. Yeah. And the bouncing off, just to clarify what Cliff is saying here, the photon doesn't change color by bouncing off. It's just that some photons are absorbed by what it's hitting, and you're only seeing the color of the photons that aren't absorbed. So that's how you can see the color of it. Some things fluoresce, so the photon is absorbed, and it releases a new photon of a different color. But yes, the color of things is all what photons are left over after they bounce off of something.
Good luck with that, Smokes. All right, we got to vote. I think we're going to do the number 2 space umbrella, help uncover Earth's magnetic shield in space. We'll talk about that more in a little bit, because I have some stellar events for this week. And we're looking at March the 6th through March 13th. And it's the beginning of the month. So remember, you can go to skymaps.com and look for their free monthly 2-page PDF download to get information on what you can see in the night sky for the month of March, and some things to go for with your naked eye, with binoculars, and with telescope. And most people have naked eyes and binoculars, and you might even be able to get to a telescope. But I think it's a really nice way to take a look at things. Literally, I have used it as a checklist. I saw that. I've written notes in the margins. I've drawn little pictures. I've put dates on them so that I know when I was out in the field doing this observing, that kind of thing. So let's see. I'm gonna kill some of these, because that's just, Let's see. I don't know what that means. Okay. Maybe I'm an alien. All right. So let's see. What? Okay. What? Used. How's that? All right, so you got that one with Cliff?
Yes.
And I don't care about that one. All right, so let's see. And I do want to...
did you show the site, skymaps.com?
No, I don't always do that.
Okay.
Skymaps.com. It's SKYMAPS.com. And you get either Northern Hemisphere, Equator, or Southern Hemisphere options. And they actually have this month and last month still. All right, so the Farmer's Almanac also has ephemeris in it, which is you can look at what's going on in the night sky every single night. And every month they do a synopsis at the beginning of the page, so that they give you a brief of the whole month. So for this one, and we're kind of past this one because it's the 6th. So we kind of missed the first thing, which is a total solar eclipse begins at 4:52 a.m. Eastern time on the 3rd, with totality starting at 6:08 a.m. And honestly, I'm sitting there on the 2nd thinking it's the next day. No, it was later that night because, of course, midnight, it's the new day. It's the 3rd. For observers in the eastern U.S. and Canada, totality begins low in the west in the bright morning twilight and is barely visible. So this was a pretty much west and south of the United States and some other areas too, like the part of the Pacific and Hawaii. Yeah. Anyway, but that is past, so we're not going to worry about that too much. But this one's coming up, the 7th and the 8th. Venus and Saturn meet low in the west. So right after sunset, go outside, take a look. Venus is very, very bright. If Saturn is near it, you'll be able to see that too. They're kind of, when they're together, it's a little bit easier to tell, especially if it's before it gets too dark and the other stars start to pop out. So the conjunction is visible through binoculars at 7:15 p.m. So that's not a naked eye thing. While a small telescope will reveal Saturn's rings to be nearly edgewise. On the 19th at 7:15 p.m., look for Venus to the upper left of the crescent moon, low in the west. On the 20th, Venus dangles below the moon. The moon hovers next to Jupiter on the 25th. Jupiter is super bright in Gemini right now. 25th and 26th, due south at 7:30 p.m. with the conjunction visible for hours. The waxing moon moves on to meet Leo's main star Regulus on the 29th. Spring begins with the vernal equinox on the 20th at 10:46 a.m. Eastern Daylight Time. So I'm going to go into the dates now. March 6th, Spica is 1.8 degrees north of the moon. March 7th, Venus and Neptune are in conjunction, and Mercury is in inferior conjunction. I think that's Earth, Mercury.
Yeah, between
sun.
Earth and the sun.
It's got to be between us and the sun.
Yeah.
Right. March the 8th is our time change. We will spring ahead. So the episode next week may be at a different time for you. In the United States, most of the country will switch, but not Phoenix kind of places, and I think Indiana, half of Indiana or something. So be aware that next week's episode could be earlier. Because by now,
depending on your time zone and whether you actually do daylight savings time or not, which means most countries, not the U.S., and certain parts of states in the U.S.
Yes, but some other places in the world do also change time a little later on. Like I think places in Europe will also, I think, spring ahead, but later than we do. You know, for us, it's going to basically Sunday. Right. All right, so let's see. And Venus and Saturn are in conjunction. We kind of covered that.
On the 8th, yeah.
Yes. March 10th, the moon is at apogee. That's 404,385 miles from the Earth. And Jupiter is stationary. Well, appears stationary. The globe at night has a new project. Yay, globe at night. It runs March 10th through March 19th. If you are in the northern hemisphere, you're going to look for either Orion or Leo. They do give you a choice for this one. In the southern hemisphere, you want to look for Canis Major. And it's really great to either do on your computer or on a cell phone. And you get to report what it's doing in your area. And I guess this is really important for understanding how bright places on the Earth are. We got some comments?
Yes.
Are they?
Yeah, so Cliff.
Are they still lively?
Cliff, we missed the eclipse. Totally overcast 30 minutes before it eclipsed. Stayed out for 2 hours.
Was it even available to see in Australia?
Not eclipse. Well,
I don't know.
Cliff, were you supposed to get a totality, or were you on one end or the other of it? And Cliff says our next episode will be 2 o'clock in Queensland.
2 o'clock, yeah. So it's right now it's at 3, and then it will be at 2.
Yep.
So yeah, just be aware. Just be aware.
And
kill some of those. Yeah, kill that.
That's a new person. Okay.
Yep. All right. So we're talking about the 10th now. We've also got Antares is 0.7 degrees north of the moon. March 11th is the last quarter moon, and the moon runs low. March 13th is our Friday night show, and a lot of times we'll give you a little teaser about what we're doing, but we got to vote. And we did get to pick the next project that we will demonstrate on Friday the 13th. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. What inspires you the most for the coming week? You want to do this last part?
Yeah, hang on just a moment. So Cliff says, yes, they were expecting totality.
Oh,
Okay.
they were. Oh.
Okay. And Don says, we had lousy weather for the eclipse too.
I'm so sorry. Northern Ohio.
So yeah, here. So if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, March 13th. Per your vote, we will be showing Space Umbrella. Help uncover Earth's magnetic shield in space. It is a Zooniverse project.
Thank you so much for voting. We really appreciate that.
Yep. And we try to show you the show that you guys, the show that you guys want. So
yeah, we totally appreciate it when you give us ideas for episodes. And of course, tonight, thank you for helping us vote.
Yep. So
yeah, we were voting on the episode for next week's smokes.
Yeah.
Yeah, we kill those.
Yeah. So
a little too lively.
Yeah.
All right. Oh boy. Thank you so much for being here. We really appreciate that. It was Dawn and Cliff, and we had some new people. PHX Snoop, Smokes is $2.99. I know Scott was here. Sally was here.
Cliff, Dawn.
I thought I saw Daniel.
Oh, and Daniel was here
because he voted.
Yeah, he voted.
He's a little quiet this time. We love your comments, Daniel.
Yeah.
All right. Did we get everybody? We had some new people. Thank you for being here.
There was Lubba.
Right on the Facebook page.
Yeah, sorry about that. I just don't know how to pronounce that.
Okay.
So
great episode, folks. We really appreciate you being here. It's always a better show when you're with us.
Mm-hmm.
And I saw something new. Did something new come up?
Hang on. Yeah, don't worry about it.
Okay. All right. So, anything else from you?
Nope, that'll do it.
We will continue to watch. Did I say Sally? I said Sally, right?
Yeah.
We will continue to watch for your comments in the future. And folks, have a great week. We are really looking forward to going to talk about the Space Umbrella, help uncover Earth's magnetic shield in space. And at some point, we will probably get to the other Zooniverse project.
Yep, because that sounded really interesting. Actually, there were 4 that sounded interesting, but I've decided to not overwhelm people with voting choices.
All right. I think that's going to do it. Thank you so much. Again, have a great week. We'll see you next Friday.
Yep. Good night.
Good night.